This video is on populations and samples. Let's start by talking about the meaning of the word population. A population is just a group of people, animals, things, or places that have something in common. Here's some examples. All college students in the US are a population because they have something in common. All people in the US military are a population, and all people on Facebook are also a population. Each of these is just a different group of people that have something in common with each other. And let's go through some important points about populations. First, a population doesn't have to be a group of people who all live at the same location. When we think about the word population in everyday life, we usually think about a group of people who all live in the same area. For example, we might think about the population of people living in San Jose, the population of people living in the Bay Area, or the population of people in California. But actually, that's really just one type of population, because living in the same location is just one thing that a group of people could have in common with each other. So all people living in San Jose are a population. They have something in common because they all live in the same city. But people who are on Facebook are also a population. What they have in common is that they're all on the same social network. And people on Facebook obviously don't all live at the same location. Also, a population includes all people, all animals, things, or places that fit inside of a certain category. When you're doing a research study, the population is the entire category of people, animals, or things that you're trying to learn about. So here's some examples. Last time I checked, there are 20,642,819 college students in the U.S. If that's true, then the U.S. college student population includes all 20,642,819 college students in the U.S. because every college student in the U.S. qualifies as a member of the U.S. college student population. Also, the U.S. military population includes all people in the U.S. military, and the Facebook user population includes all people on Facebook, but who knows how many people are on Facebook these days. Another point is that populations can overlap. For example, college students who are on Facebook are members of two populations. They're members of both the college student population and the Facebook user population. The fourth point is that a population doesn't even have to be a group of people. A population can be a group of people, animals, things, or places, as long as they all have something in common with each other. Here's some examples. All mountain lions in the Bay Area are a population of animals. All $5 bills in the U.S. are a population of things. They all have something in common because they're all worth $5. All 50 states in the U.S. are a population of places. So a population could even be a group of places. For example, all cities in the Bay Area make up a population of cities. All of the cities in the Bay Area make up a population because they all have something in common with each other. So why do we care about populations and statistics? The reason why we care about populations is because the purpose of collecting a data set is usually to learn something about a population of people. For example, if I went up to 100 different iPhone users and asked them how much text messaging they do each week, I'm probably not interested in learning about those 100 specific people. I'm probably interested in learning something about the entire iPhone user population. So a person who collects data from a group of people is usually trying to learn something about the entire population that group of people comes from. So how does a person collect data to learn about a population? Well, in a perfect world, a researcher would collect data from every member of the population that he or she is studying. The reason why is because if you collect data from all members of a population, you get perfectly accurate information about that population. Think about this. If I'm interested in the average or mean GPA of all college students in the US, and I go out and I record the GPAs of all 20,642,819 college students in the US, I could use that data to actually calculate the exact average GPA of the entire US college student population. I would just have to add all of my answers and then divide the total by 20,642,819. And then I would have the exact average. So if you collect data from all population members, you get perfectly accurate information about the population. The problem is that most populations that people are interested in studying are so large that it's not possible to collect data from all members of the population. You can imagine how difficult it would be, or how time-consuming it would be, to collect data from all college students in the US. So typically it's not possible to collect data from all members of a population, either because it's too time-consuming, it's too expensive, or it's not even possible because some members of the population can't be contacted or reached. Maybe some people in the population don't have a phone or don't have an email address. So instead of collecting data from all members of a population, the researcher almost selects a certain number of volunteers and then collects data from those people only. The selected group of people or participants that participate in the study and provide data to the researcher are called a sample of the population. So if I'm interested in whether college students in the US aren't getting enough sleep, and I go out and I find 100 college students who are willing to take my survey, and I ask each of those 100 people how many hours of sleep they're getting per night, those 100 people are my selected sample of college students. They're the selected group of people that I'm collecting data from, and all 20 million college students in the US are the population that I'm trying to learn about. So what I'm doing is I'm collecting data from the members of my sample to try to learn something about the population that they belong to. Here's an example of taking a sample from the population. The population is the entire category of people that I'm trying to learn about, and the sample is the selected group that I actually collect data from. The other members of the population who are outside of the sample don't provide data to the researcher, so their data values are actually unknown. Here are some examples of selecting a sample from a population. If a person records the GPAs of 75 Stanford students to learn about how well Stanford students are doing in their classes, then the population that's being studied is all Stanford students. This researcher is trying to reach a conclusion about Stanford students. The sample is the 75 selected Stanford students who are providing data to the researcher by taking the survey. What if another person is interested in how much money is being earned by Google employees? If that person goes out and finds 100 Google employees who are willing to take a survey, and those 100 people tell the researcher how much money they're earning, then well, the population that's being studied is Google employees, because the researcher is interested in reaching a conclusion about Google employees, and the sample is just the 100 selected Google employees who are actually taking the survey and providing data to the researcher. What if I'm interested in recording the number of hours? What if I'm interested in whether college students in the US are getting enough sleep, and I ask 130 college students how many hours of sleep they're getting? Well, in that case, I'm collecting data from a sample of 130 college students to try to learn something about the population of all college students in the US. So, in a research study, the sample is the group of people that participates in the study and provides the data, and the population is the entire group of people that the researcher is trying to reach a conclusion about. And one thing that can be confusing is that whether a group of people is a population or a sample can actually depend on the study. For example, if I'm interested in reaching a conclusion about Stanford students, and I collect data from all Stanford students, then I've actually collected data from all members of the population that I want to learn about, because I'm just trying to learn about Stanford students. But if I collect data from all Stanford students as a way to learn something about the entire US college student population, then I've actually collected data from a sample of the population that I want to learn about. Now we'll talk about the idea of sample size. In a research study, the sample size is the number of population members that are included in the sample. Let's find the sample size in each of our 3 earlier examples. If a person is recording the GPAs of 75 Stanford students, then the 75 people that data has been collected from are the sample, and the sample size is 75. If a person is recording the incomes of 100 Google employees, then the sample includes the 100 Google employees, and the sample size is just 100. So the sample size is just the number. If a person is recording the hours slept per day by 130 college students, then the 130 people are all members of the sample, and the sample size is just 130. Let's now talk about sampling methods. There are different ways to select a sample from the population, and the 2 main types of sampling methods are random sampling and non-random sampling. Random sampling involves some type of random drawing or lottery system that gives all population members an equal chance of being selected to be in the sample. If I write down the name of every population member on a piece of paper, put all of the names into a hat, and then shake it up, and then pull out names without looking, that should be random, or at least pretty random, as long as I'm doing it fairly. Also, one way that random sampling is often done in actual research is by doing something called random digit dialing. That there are computer programs that can create random phone numbers that are then dialed to reach possible participants. And when if you assume that each person in the population has a phone, then random digit dialing gives each population member an equal chance of being selected. So random digit dialing would be an example of random sampling. The opposite of random sampling is non-random sampling, which is when participants are not selected randomly. If the researcher picks and chooses participants, or if the researcher puts up an advertisement and lets people decide whether they want to come forward and participate, that's non-random sampling. In either case, the participants aren't being selected by a random drawing, and non-random sampling doesn't give all population members an equal chance of being selected. The major difference between random and non-random sampling is that random sampling gives all population members an equal chance of being selected, and non-random sampling doesn't give all population members an equal chance of being selected. And if I If I want to select college students to take a survey, and I walk around a college campus, and I walk up to students and ask them if they would like to take a survey, that's non-random sampling, and it doesn't give all population members an equal chance of being selected. The reason why is because I'm probably going to be more likely to walk up to some types of people and less likely to walk up to other types of people. People who look like I'm going to be more likely to walk up to people who look like they would be willing to take the survey, and I would be less likely to walk up to people who look like they would be less interested in taking the survey. I might also be more likely to walk up to people who look more friendly or more approachable. So um, when you go around a public location and you walk up to people and ask them if they would like to take a survey, that's not random sampling because you're really just picking and choosing people. You're not giving all population members an equal chance of being selected. If I put up an advertisement at a college campus and I say that I need people to take a survey, then that's also not random because um, not all people in the university's population will have an equal chance of being selected. Some students will be more likely to see the advertisement, and other students will be more likely to not have the opportunity to see the advertisement. Um, Students who, for example, if I put a flyer up on a certain board on the campus, students who happen to walk by that board on the way to class will see the flyer, but students who take classes at other areas of the campus might never walk by that board and have a chance to see the flyer. Also, the people who do walk by the flyer won't be equally likely to stop and read it. Students who are more tired or stressed will be more likely to walk right by the flyer and not bother to read it. Or students who are busy might be more likely to just walk by. And other types of students will be more likely to stop and read the flyer. So um, putting up a flyer or an advertisement is also non-random sampling. It doesn't give all population members an equal chance of being selected. So here are some examples of random sampling, and here are some examples of non-random sampling. We talked about using flyers or approaching people in public locations.